Okay, thank you very much. My talk is about Angular dependency injection. My name is Peter Eijgermans. I work for Ordina, a Dutch company, and also for the department JS Roots, which is specialized in front-end technology. And you can find me on Twitter, of course, here. The contents of my talk is what and why dependency injection. I want to show you dependency injection in action. I want to show you how to, what are the hierarchies, the element and the module hierarchy we can use, and the lazy loading modules and dependency injection I'm going to talk about. Finally, I finish with resolution modifiers and dependency providers. What is a dependency? Dependency, you see here. Imagine that you have module A, which needs module B and C, and then module B and C is a dependency of A, of course. And you see here a problem how it looks like in code when you have a dependency, and here you see the wrong situation that you have here. A hard-coded situation of a dependency. The car has a dependency engine or electric engine, but it is very static, and it is also, the car is also responsible for creating the instance of the engine, of the dependency. That is not what we want, of course, because this is very difficult to test also this thing, because you cannot inject here a mock engine, for example. So it violates the single responsibility. So it is the class is here responsible for creating the engine, and it is not flexible. Everything is tightly coupled. Here you see a solution where here we create our engine at another place, somewhere else. Here we inject it here in our constructor outside of the car class. And that is the better way. So now it is better testable. Here via the constructor, we get the right engine. And now we can also use mocks, for example, to test, and also inject other engines, a gas engine, electric engine. The car is not responsible for creating the engine you see here, and that's a good thing. It is better to test, better use it, and it is not coupled anymore. You see here also the inversion of control principle, that concrete classes are created somewhere else at another place, not in the class itself anymore. And an implementation of inversion of control is dependency injection itself. Dependency injection is a programming technique that makes a class independent of its dependencies. Dependency injection in Angular. How do we do that? You recognize it, I think. Here we create a component in Angular with this annotation, and it has a selector. That's the name of the component. It has an own template, and also there's a constructor where we pass in our dependency, our engine service, for example. And I've also created a method to test if the engine is working. That is okay, and this is a good way to inject dependencies in Angular. What do we need? What is under the hood? What do Angular under the hood? It uses an injector. An injector is responsible for creating the class instance. Here we see that it is under the hood. It is creating an engine service with new, and it also injected here via the constructor in the car component. So this is what the injector do. Dependency injection in action. I can also show you something about it. Here is a very simple application I've made here. And you see here that I define here upstairs a engine service. Engine service has a run method, and it only has a console log engine is running. And we have also a car component, which is using this engine service. Here we have a constructor where we can inject it. We see, let's see how we do that. And here I have the simple method to test it if the engine is working. But what do we need more for this? To make this workable, to connect the engine service to the car component, I define here a injector. Injector, I define here upstairs a container, which is nothing more than a map with a key, a string, and any for the service I want to hold here in. It consists of a constructor where I pass in my providers, and those providers contains my services I want to inject. And I loop through the services, through the providers with the for each, and then I set an entry in the map, in the container map, with the key of the name of the service, and I also create an instance of the service, which I provide here. I've also made a method, a get method, to get the service from the container. So you can see it here. If there is no instance found for a certain key, then we get the error, no provider found. So this is the way how Angular, a simplified way, how Angular is doing under the hood. And how do we use this in our application? Here we have the providers, and this is nothing more than an array of services we want to inject. And this we inject it here in our injector itself, engine service, via the providers property. And the injector will create a engine service instance, a singleton it creates for us. And so we can use the injector now to get the singleton engine service and pass it here in the constructor of the car component. So that is what is Angular doing under the hood. When you see here the logs, and when I try to start it, run, then you see here the text engine is running. So it is here, you see the console log, engine is running. This run method is called here, sorry, is called here in the component, of course, via the service. And this is what I do here. Is engine working? I'm calling here. So this is dependency injection in action. I've explained it already. I define here some providers. That is the main thing. What we're doing here, and we pass here to the injector. So the injector is able to create singletons, new instances for the engine service or tire service, and pass such an singleton, such an instance in the constructor of the car component. So we provide here services, and via the injector get, we get the instantiated singleton service. So now we can call the method component is engine work. You see here that providers, we also always pass here an array. This is also how we do that in Angular. You recognize here in the Eijgermans module annotation decorator. We have here a property, a section providers, also an array with what you want to provide. And under the hood, the injector will pick it up and create a singleton for you, which you can inject. You can also nowadays provide your service in this way with an injectable Providedin root, which means that this service is available in whole application. It is visible in the whole application. And the other advantage of this construction is that this service is tree shakeable. That means that you can remove the service from the bundle when it is not used. From the final production bundle, you can remove it. That will be automatically done. In Angular, you have two injector hierarchies. And they are responsible for creating and for getting our services, for resolving our dependencies. We also say for our components and for our modules. We have a module injector hierarchy where we register our module level services. We have also element injector hierarchies where we register our services at component or directive level. What's the purpose of these hierarchies? It determines the scope or the availability of the service in our application. I will show you later in a live example. Module injector here in the Eijgermans and injectable, we've seen it already. There we can predefine our providers, our services we want to provide. And this is all that we register it here at module level. At element level, the element component and the directive is also an element. We can define also providers, you see here. But how does that work? I will show you. The module injector, let's look up. What is that? It starts with a root injector. Services which were configured in eagerly loaded modules, we can also say, and modules with injectable Providedin annotations. They were always use the root injector. What does it mean? We define it in this way: a service in root or in the app module at this level. Then this service is available in the entire application. That's very important to know. You can also define a service via Providedin platform. So the service is available in the platform. You can use that when you have a single page application with multiple applications on one page. So there can be provide services via the platform injector. The null injector throws an error if Angular cannot find any service here. And we have also a child injector. This injector is created for every lazy loaded module. Lazy loaded module, a little bit too small here. I'll show you later, is created or loaded during the creation of routes. So you see it here, lazy load module in the routing. Here we create loads a LazyModule via the path lazy, load children. We can load here our a module. I call it also already LazyModule, and this module will be lazy loaded there. But what is lazy loaded and what is eagerly loaded modules? Eagerly loaded modules are modules which are by default they are loaded during a startup of your application. But lazy loaded modules, when you have a big application, you get also it is needed to use also lazy loaded modules because they are loaded only when you need it. These modules, not only at startup time. They are created in the routes. They are loaded via routes, and the advantage of lazy loaded modules is that its initial bundle size is smaller, and it decreases the load time of the application. That's very good. Here, so you see again how to lazy load a module in Angular. I've shown you that already with load children. The availability or scope of provided services. What is the scope? Where can you? What's the visibility of your services? I start here with eagerly loaded modules. We define it this way. Then, if you provide some service, like here in an eagerly loaded module, ng module, it will be added to the root injector, which makes it available across the whole application. So it's a very important one. But with lazy loaded modules, you define it really the same way as this one. You see it. But if you provide some service in a lazy loaded module, the service is available only in the lazy loaded module and not outside of it. There are a lot of situations. I've made a table of it. When you provide a service, what is then the scope in the when you provide a service in an eagerly loaded module in the engine module, then the service is available, visible, application-wide. But when you do providing a service in the engine module of a lazy loaded module, then it is available only in the lazy module. When you use injectable with Providedin any, then it is application-wide available. But for a lazy loaded module, it is only available in the lazy module. When you use Providedin root, you've seen it already, it is available, visible. The service is visible at application level. Application-wide, it is available and you can use it. Also for lazy loaded models. And they are tree shakeable. So if the application does not use this service, finally, in the final production bundle, it will be thrown out. It will be removed, this service. The injectable with Providedin platform, when we use that, then for both, the service will be available at platform level. And when we inject provider with Providedin lazy module, or a certain lazy module, not really this name, but can be a lazy module, and we inject it in an eagerly loaded module, then we get an error. Else, in the lazy loaded module, it is only available in the lazy module itself. Here you see an injectable with provided any. I've also explained it. Here at application level, it is available. So you can also say eagerly loaded modules. What happens here with provided any all eagerly loaded modules? These are eagerly loaded modules. share the same singleton instance of the engine service. When we use Providedin in lazy loaded modules, each lazy loaded module get their own instance of the engine service. So it works. This is the way it works. Element injector hierarchy. How is that working? That is, here we're talking about providing services at component or directive level. This is okay. And this, you see how we, the element injector starts at the top. You can define here a root component. In this, I call it here root car component. And I've defined here a provider for engine service. I also have child element injectors for child components or for grandchild components. We can also define our own providers, of course. Dependency resolution. How does that work, all those hierarchies? Let's step into this. We have two hierarchies. Angular resolves the dependency in these two phases. First, it starts here at the element injector hierarchy underneath, when the grandchild component wants to resolve a dependency, but it does not have it itself. It goes up and it looks if it can resolve its dependency in this child element via this child element injector. If there is not if it cannot resolve this dependency, it will look here upstairs, and you see here it provides here an engine service, and that is okay. So I inject here the engine service instance from the root car component. From the root car component injector, I pass it and inject it into my grandchild component. That's what you're doing here. That works. But what if the dependency could not be resolved in an element injector tree? Then we step over to the module injector hierarchy. I start here looking for my service, or if I can resolve it here, my service, my dependency. If not, I go up and up, and if I don't find anything, I get an error. This is how dependency resolution works. We have also a child injector. This injector is created by every lazy loaded module you create. And when this is available, we start our searching here. We start resolving our dependency here. I have an example about hierarchical dependency injection. It is on StackBlitz, and you see here some situations, some scenarios. How does this example work? You have here a app component, app level. You have child components, parent and childs, two parent components underneath, and you have also a routing component. So when you click on the Eiger, you see here the Eiger component. I'll show you later. The app has a app module, 3 modules: app module, Eiger module, and LazyModule. And all modules have one service each. They have an app service, and the Eiger module has a Eiger service, and the LazyModule has a LazyService. Each service generates a random number, and all components inject all services and display the results. This is how a app service and also the Eager service and the LazyService looks like. It's nothing more than a simple service. There's a constructor, and it generates here a number, and it will, with the getSharedValue, we can grab the generated random number. And this is what we're going to show you here. These are these numbers. So you can recognize where my service is injected. Here we have a scenario, provide services in the module. So in the first situation, we provide all our services in our own module. So the Eager service I provided here, and the app service I provide in my app module, and the Lazy module contains the LazyService. What should you expect when I change my program with these properties, with this situation? The app service and the Eager service are all registered in the root module injector. So they are available application-wide. Now, these two. This one is application-wide available, and this is an Eager module, though, so this is also application-wide available. For a Lazy module, this is different. For the Lazy module, the LazyService only available in the Lazy module itself. Okay, let's look here. We have here. Let's open it. In the app module, I said I define here my provider, my app service here, and in the Lazy module, I define here my LazyService at this level, and in the Eager module, I also define it here. So that is okay. When we click on these links, these routes, you see that everywhere, Eager module also, everywhere you see it is application-wide, it is available, all components know what the value of Eager is. But when we click on Lazy, the other components are not cannot see the value of the Lazy service. So the LazyService is not visible, is not available in these components. You see it only here. It is only available in its own Lazy component. That's a little bit of a recap about how this works. Here we see some routes. I define here Lazy, these routes, and I inject here all my services via the constructor, and I do that in every component. I have here also defined an optional. I will explain it a little bit later, but that means that when there is a null value, you get no error in your screen or in your console log. And here we grab our generated random values from the service. And these services, you know that already, looks like this. There's a constructor where it generates for each service, here for the app service, it generates a random number. And here for this method, the getSharedValue, we can grab the shared value. The Lazy component also injects here all our services we have, and also grab here all those random numbers and also displays here in his template all those numbers. And the eager component also injects all those services, grab all those random numbers from the numbers from those services, and also shows it in the template. So this is why this is how it works here. I want to step over to scenario 2. I want to use the Providedin in the LazyModule. So I have now in the LazyService, I have only defined here injectable, anti-injectable, but I want to change it with Providedin root. So the LazyService will be available now application-wide. Why? Because when you define it this way, the service is added to the root module injector. And the root module injector always is available application-wide. And the advantages of this construction is this injectable Providedin root. Advantage is it is tree shakeable. And on the other end, we remove the LazyService from the LazyModule providers here, providers area. What will happen then? What will happen here is, in this situation, is that the LazyService is now available in all the application. It's now visible in all the application. Let's go here. LazyModule, I want to remove this one. And in the LazyService, I define it here now as Providedin root. I've already done that. So this LazyService is now available application-wide. You see it here. It is here available, everywhere available. Also, when you click on other routes, okay, go further. For situation 3 is to keep this in the root and also add my LazyService to providers array in the LazyModule. I add it here again. So it is in root, but also defined at the LazyService. Now this will, our LazyService will be available at 2 places, available at 2 injectors. It will be available in the root injector, and also it will be available in the LazyModule injector. So 2 levels. Let's go. LazyService. Let's copy the value here. Here it is Providedin root. That is good. And in the module, I add it here again. I don't know what we get it here now. LazyModule is available in whole application, but also it has its own lazy injector, which gives its own LazyService back with another value. Okay. And also I want to show you the situation to add my LazyService to the providers array app component. To add your service. Okay, let's do that. templates again. If you have a situation where here you have the situation that I have in the component itself. This is in the element injector tree I'm now busy. I will provide my LazyService here in the providers area. So now the LazyService is now available application-wide, but it is also available in the LazyModule and also in the app component itself. So 3 levels. And then you have the fifth scenario, service in a component. When you register the app service in the provider array of the parent component 1, then it will be, the child of the parent component, it is visible there then, the service, but not in the whole application anymore. Resolution modifiers. What is that? We have some resolution modifiers, and the first one is self. This is this one. You can edit here. And what does it mean? It tells Angular that it should only look within the local injector. It will look if there is a provider there for this service here in its own local injector. But it does not have anything, so it will throw an error. This is what self do. It only looks here, but it is not defined here, so it results in an error. Then we have also the skip self. That's another one. And that means that you have to skip your own injector and start here with your parent element. In this case, the child element injector, to resolve our dependency. And then we have the third one, the optional. That is that will say, we've seen it already. This will not throw an error if it cannot find any engine service in this case. And then finally we have also the host resolution modifier, and it tells Angular that it should resolve dependencies in the scope of the current directive or the current component where it belongs to. Dependency providers. This is the last part I want to talk about. We have 4 dependency providers: use class, use existing, use value, and use factory. Let's start with use class in add component. You can use it here. We provides a new instance. We can provide here with use class a new instance of a certain class. You see that it is, we use here a injection token here. That is the key of our map I've defined here. I can show you. Wait a moment. Here in my simple example, I've also here an injector, and I have here a map. And it has also, a map has also always a key and a value. And the key is the injection token I show you now. And the dependency is this part. This part is the new service I want to make. This is the injection token I use in my map, my key in my map. And here we have the dependency we want to have an instance of. And here you have the providers. This is nothing more than a combination of our provider and our dependency we want to create. And finally, of course, we have the injector, which creates our singleton, which we can here inject in our component via the constructor. We always use a unique injection token, so we are sure that we create unique tokens. In Eijgermans, we can do the same, of course. We can also define our providers this way with the use class. But you recognize this. There is also a shorthand way to do this, and we recognize this from the previous examples I showed you. You can do it this way when the provider and the use class are the same, of course. And we have a use value. If you need to provide a value like a string, you will provide it with use value, a string, or an object, or an already instantiated class instance. Here we pass in the value my title into this injector, and here we can inject it. We can inject the title in this constructor. Use existing, it's a kind of an alias. We use here an already existing instance of a LazyService. That's what you can do also. And finally, we have the use factory, which you can perform some logic to create an instance. Here we provide, here we have a injector token food service we want to create. And we define here a factory. This is nothing more than a factory method to where we create our food service. And we also have a dependency. I show you, you can also, a dependencies part where you can pass in dependencies which you want to use in your factory. Let's see how we do that at runtime. All right. I have an example of here we provide our food service, and we have here a factory method, drink factory. And this drink factory has also a dependency HTTP client. What does it factory do? Here upstairs, we pass in our dependency HTTP client to do HTTP calls. And we create here our new food service. And we pass here our unique URL you want to fetch data from. We want to fetch drinks from the food service. We have also a pizza viewer component, which has another URL, API pizzas. And we have here a site viewer component, which has this URL, sites. So this is our factory, which creates a food service. What does the food service do? Not so much. Here we pass in our HTTP client and our API string, and we get our food, what we need. So that is why we get this. This is our drink, this is our pizza we have ordered, this is our chicken. So this is one of the ways how you can use such a factory. Okay, now let's wrapping it up. I have talked about dependency injection. That is a way of architecting your application. I've talked about inversion of control and dependency injection in general. Showed you some examples. And the dependency injection framework consists of 4 concepts. talked about token. It also, I hear some more noise now. The token, and it consists also about you've seen it by the use class. A dependency, and it consists of an injector and providers. We have talked about dependency injection hierarchy, resolution modifiers like add skip and add self and add host. And I've talked about dependency providers like a use class and use factory. Well, thank you very much.